after creating my initial concept in SOLIDWORKS, testing it for drag with flow simulation, optimizing the parts for strength and weight with Inspire and SOLIDWORKS simulation, the parts were then ready to be 3D printed. Because I wanted high quality, durable 3D printed parts, I chose to use our Fortus line of 3D printers from Stratasys. These printers use fused deposition modeling, also known as FDM, for direct digital manufacturing. This allowed me to not just get a fit and form prototype, but instead print fully functional production grade parts. For this project, we chose to use ABS Plus material because it met our strength and durability requirements at the lowest cost. The kayak will be covered in clear vinyl, so I decided to build the 3D printed parts in both blue and white to help show off the internal structure. In order to print the parts quickly, we used multiple printers including the Fortus 250, the Fortus 450, and the Fortus 900. Because some of the parts were very small relative to the build chamber size, we were able to print many of the parts together, saving on time. In all, we printed a total of 41 parts, resulting in just over 250 hours of print time, 327 cubic inches of model material, and 298 cubic inches of support material. The cockpit was built as a single part on a Fortus 900 and took 101 hours to build. While we could have divided the part up into sections and glued the cockpit together, having the ability to print an entire large part at one time reduced the manual time to glue the parts together, ensured a single strong part, as this was where I would be sitting when out on the water, and ensured that the final piece was dimensionally accurate. Parts were printed with soluble support material to accurately print the unique geometries of the kayak parts. Support was easily removed by hand and with soluble support stations, dissolving the material from the more intricate, harder to reach sections. Because one of my goals with this project was to reduce the amount of man-hours to build a kayak, I put a variety of assembly features into my 3D printed parts. In the bow and stern areas, I created pockets to accept my wood stringers. This allowed me to simply cut off my wood parts square and allowed the complex blending of the curvature to occur in the 3D printed part. I also included locating pegs in all my 3D printed sections. This meant that all I needed to do was drill some simple holes in my wood stringers, and when it came time to assemble, it was just a matter of lining up the pegs with the holes in the wood. With my 3D printed parts completed, I then used clear pine for my wood stringers. I glued the stringers to the 3D printed parts using a plastic specific epoxy. Because pine is not very rot resistant, and to prevent the wood from absorbing water in the event of a capsize, I also used 2-part epoxy both for waterproofing the wood and for fiberglassing on the bow, stern, and cockpit ring to reinforce where the plastic parts may not be quite strong enough on their own. When building a typical skin-on frame kayak, it would take me 40 to 80 hours to build. Much of this time is from needing to cut and fit all the stringers and frame sections. Because the build is somewhat fluid, you often cut a piece, hold it in place, mark what still needs to be cut, and then repeat the process until everything is fitting properly. With the 3D printed kayak, I built many of the hard to fit geometry directly into 3D printed pieces, leaving simple geometry on my wood pieces. Not only did I not need to cut the sections, but the stringers were much simpler to make. Finally, because of all the printed in assembly features, there was not any appreciable refitting needed. It was just a matter of lining up the locating pins with their locating holes in the wood pieces. Once we had the frame glued up, the last step was covering the boat with clear vinyl. While this portion of the build is not much different than any other boat built with a vinyl covering, I was confident that the shape would be wrappable because of the work done in SOLIDWORKS to ensure smooth, developable surfaces. In total, it took about 20 man-hours to build and assemble the kayak. With the last glue seam dry, it was time to test the kayak. We started by taking a few glamour shots on the beach. Then it was finally time to put the boat in the water. I must say it was very exciting to see the kayak float for the first time, after so many months of planning and building. The kayak has good secondary stability and produces almost no wake. Because of its length and hard keel line, it tracks very straight, and I believe it is most at home in open water. It is exhilarating to take a concept all the way through to a finished design, and with SOLIDWORKS and Stratasys, it makes getting there much, much faster.